In this video, we're going to be going over the domain and range of a function. And this is our part 2 video inside of Math 20-1. So let's get started with this video. So starting off, we're going to talk about domain and range. And the first thing that we're going to do is define what a domain and what a range actually is. So the collection of all the possible inputs for a function is called the domain of a function. And the collection of all the possible outputs of a function is called the range of a function. So inputs are a domain and outputs are a range. So for an example, identify the domain and range for each of the functions. So in this case, we have this mapping system here, and basically we need to find out which one is the domains and which one is the range. So as we said previously, the domain is all the inputs and the range is all the outputs. So in this case, the left side here would be the inputs, so the domain would be 7, 4, and 1, and then the output, which is the range, would be 2 and 3. So this is how it would look like. The domain would be 7, 4, 1, and the range would be 2 and 3. And when we list out these values for domain and range, it's really common to put them inside of these curly type of brackets. So this is how you can list domain and range and what the domain and range actually is. So moving on, we're going to look at another example, which is a graph plot. So this is how our graph looks like, and the x-axis is this horizontal line, and the y-axis is the vertical line. So in this case, we need to find out the domain and range of this graph plot. So in order to do this, we can remember that domain is the inputs, and in this case, the inputs represent x. So we would look at where it is placed on the x-axis. So you can see here, this one is on -3, so that would be one of the points. Another one would be -2, another one would be -1, then one would be +1, +2, and +3. So the domain would be those numbers, and then for the range, what we would do is we'd look at where it lands on the y-axis. And also another thing for the range, we do not count multiple things. So for instance, if we have multiple points on the range value, we only count it once. So for example, we can see here that on y2, we have 2 values, so 2 different ones. So in this case, we're only going to count it out one time. So we're going to have 1, which is 2, and then we're going to have 1, we're going to have 0, and -1. So if we look at the answer here, the domain would be -3, -2, -1, 1, 2, and 3, and then the range would be -1, 0, 1, and 2. So we don't include both of these twice, because in the range we do not do that. And also another thing to keep in mind is that when writing domain and range, you always start from the smallest number to the biggest. So that's why we start off with the negatives and then we move on to the positives. And also, as we just said before, there's no need to write the repeated values since it is a collection of possible values. So in the range, we do not write these repeated values, and for the domain, we're never going to have multiple repeated values anyway. So moving on, for example 3, we're going to look at a table. And this is how the table looks like. So now we need to find out the domain and the range for this. So in this case, the domain would be the name. So then we're going to have Olivia, Mia, Noah, Lucas, and Emma in the domain. And in the range, we're going to have 15, then 16, 17, and 18. And we don't count 17 twice. So if we look at the domain, we have Olivia, Mia, Noah, Lucas, Emma, and for the range we have 15, 16, 17, and 18. And once again, we don't have to write 17 twice. So moving on, now we're going to look at an example of a function. So what we need to do is determine if the following relation is a function, and if it is a function, then we need to list the domain and the range. So we're going to have the table again. So let's see if this is a function. So if we remember, a function is basically when there is one x value connected to one y value. So for every single input, there is one output. So if we look at here, -2 is connected to 2, -1 is connected to 1, 0 is to 0, 1 is to 1, 2 is to 2, and 3 is to 3. And so in this case, this is a function because for every input, there is a singular output. So every x value is connected to one y value, so this is a function. And for the domain and range, we're going to have -2, -1, 0, 1, 2, 3. And for the range, we're going to have 0, 1, 2, and 3. So that summarizes this question. So now for this question, determine if the following relation is a function, and if it is, list the domain and range. So in this case, we're going to have an equation, and this side we have y is equal to x. And if we were to plot this onto a graph, if we can just imagine, it would be a straight line that goes from 0 to 0. that goes through 0, 0. So in this case, this y is equal to x is a function. So since it is a function, we have to list the domain and the range. And this is a function because every x value is actually connected to one y value, so that makes it a function. And the domain and range would be all real numbers because y is equal to x, that's infinity. It'll just keep on going through. So that's why we write all real numbers. So that summarizes this question. And now for the next question, we need to do the same thing, just determine if it's a function. And in this case, we have a mapping flowchart. So in this case, 9 is connected to 10, 8 is connected to 1, 6 is connected to 7 and 9. So in this case, this would not be a function because one of these inputs is connected to multiple outputs. So since it's connected to multiple outputs, this would not make it a function. So this is not a function because 6 is connected to both 9 and also 7. So that summarizes everything for this video. Thank you so much for watching from Try to Be Useful, and we'll see you in our next math video.